in 5 hours. That's all we need out of that. How long together? So I'm going to cut out all those words, get right to the point. How long if they work together? Okay. These actually are some of my favorite kind of word problems. I know that sounds weird, huh? Because I used to, you might think I just came out of the womb loving word problems, but I hated them. When I was taking algebra, I remember in high school, I hated word problems. I thought they were unreasonably hard and unfair, and no regular human being could solve them. Only freak weird people. But eventually, after doing a million of them, you can solve them. So anyway, these kind always seemed weird to me because when I would read these are words. So we're going to have 3 kinds of word problems in this section. These kind won't be too bad. These are called working together word problems. We're going to do like 4 or 5 in a row that are all about person A, person B. And then they work together. How long will the job take? You have hose A and hose B filling the pool. How long for both hoses? It's going to be all these problem after problem where you have one person, another person, one hose, another hose, one computer, another computer. Then they work together. How long will it take? So, how do you handle working together problems? Anybody have an idea? If it takes Lisa 4 hours alone, that's all by herself, And if it takes Bill 5 hours, can you read that? My 5s look kind of funny. 5 hours alone all by himself. How long if they work together? Let's just be logical with it for a minute. You know what it is? 9. Yeah, that's how I felt too. And you laugh because you can't be 9, huh? But I felt the same way. I felt like adding. That's what was weird to me. I would read it and I go, oh, I want to add. I want to go, 4 hours for Lisa. Bill helps. Together, add them up. Whenever they combine, we add. 9 hours. 9 hours. But that's crazy, right? It can't take them longer together. They must not get along very well, right? I mean, that's not right. So, but I felt the same way. And we will add something in the end. It's not quite like this, but adding is the right feeling. You just don't add these. Anyway, so it can't be 9. What other thoughts do you have? Let's try to get there. So hold that adding feeling. It's the right feeling. Divide by the total. What total?
Together.
Okay, so what number do you need?
The x.
The x? Hey, just do x. What is x?
Together.
Together?
Is the x.
So you probably make up an x and say it's together and divide by?
And then use the formula they're going to give us.
How about just logic? Just give me just logic. What do you guys think the answer is? How about we just guess at the answer? Let's just be logical with this one thing. Somebody had to just guess. What do you think?
Maybe we can add and divide by 2.
Good, yeah, because what happens when you add and divide by 2? You get the average. Yeah, average is a great idea, right? How about we add them and divide by 2? Get the middle. Get the average, right? Averaging. Because, they're working together, average effort. So if you add them and divide by 2, 9 over 2, divide that in your calculator, you get 4.5, which we know that is the middle of 4 and 5. 4.5. How about that answer? 4.5 hours? That seems like a good answer? Tom, right?
Yeah.
I saw you shaking your head. You don't like that answer?
No.
Why don't you like that answer, Tom? How do you know that that's a bad answer?
Because that's already, Lisa is only like 4 hours. So it's already more than Lisa.
Yeah? Lisa can do it by herself in 4 hours. So when Bill comes to help, it goes up to 4.5 hours. I think that's how my wife feels sometimes when I try to help in the kitchen. So, yeah, it gets worse. That can't be the answer, huh? Yeah, I mean, it makes sense at first, and then we go, oh, no. The real answer has to be lower than 4. Right? Doesn't it? Because Lisa can do it alone in 4. If Bill's any help at all, then the real answer has to be lower than 4. Doesn't it? So it's weird. How do we get like a lower answer? Even though we sense it's got to be lower. How's that happen? Let me ask you this. Say we go, all right, Lisa and Bill, just get working. Boom, and they just start working. And after 1 hour, we clock them, and 1 hour we stop. Okay, so how much of the job, let's just talk about Lisa alone. Lisa can do the whole job in 4 hours, right? Whatever this is, clerking or whatever it is. She can do, let's say it's painting a room. She can paint the whole room in 4 hours. So if she works alone for 1 hour, after 1 hour, what portion of the room is painted? Lisa can do the whole room in 4 hours, then in 1 hour, what does Lisa get done in 1 hour? What portion of the room? 1/4, right? If she can do the whole room in 4 hours, then after 1 hour, she gets 1/4 of the room done, right? And in that same time, in that 1 hour, what will Bill get done? If Bill's in the other side of the room, painting for his 1 hour also, when we stop him after 1 hour, what portion of the room will he have painted? He can do the whole room in 5 hours. He'll get 1/5 of it done. That makes sense, right? You good with that logic? So in one, if we let both of them work, Lisa, you start there, Bill, you start there, ready to go. And we let them both work for an hour. Lisa can get the whole room painted in 4 hours, so in 1 hour she gets 1/4 done. Bill can get the whole room painted in 5 hours, so in 1 hour he gets 1/5 of the room done, right? He would get 1/5, 1/5, 1/5, for 5 hours and have the whole room done, right? So if we add up the total amount of painting they both did in that hour, we get the together, don't we?
Yeah.
We get the amount of painting they got to get done together in 1 hour, anyway, right? It's good so far. Now, I don't know what that is. I mean, I don't want to mess with common denominator right now. But let's just say it's X, because that's what they're asking, right? How long together? So like Claudia was saying, let's call that X. That's hours together to get the whole job done. I don't know what that is, right? Let's call it X. X is how many hours it takes them working together to get the whole job done. Now, let's use the same logic for a minute. Just forget about this stuff over here for a minute. Let me just do the same logic over here in 1 hour together. Think with me. What if, now I know we don't know. You think, well, we don't know. Right, we don't. It's X. But suppose it was, we already said it has to be smaller than 4. Maybe it's 3. I'm just totally guessing. I don't think it is, but let's just guess. Suppose somebody told me it's going to take them 3 hours together. Let's just suppose that's it. So notice what I'm doing. I'm trying to attack a problem that I don't understand by biting off small bites and simple numbers that I can think better with. Do you notice this strategy here? That's more important than you're never going to be asked in your life, other than the test in 2 weeks, to do one of these word problems, right? In your real life, you're never going to be asked to do one, but you will be asked to be a problem solver in whatever job you do, and to attack a problem, learn how to think, logically break it down. All this. That's the real value here. Notice the thinking I'm going through. I'm going, let me think what I do know. Take what you do know and think of simple examples. And say, okay, what if somebody just told me 3 hours? It's going to take 3 hours for them together to get the whole room right. Lisa and Bill, go! And they'll work and both paint. After 3 hours, they did it. The whole room. If I stop them again in 1 hour, I'm going to keep doing this stop them after 1 hour thing. If after 1 hour, they're both working together, work, stop after 1 hour. If it was going to take them 3 hours together to get the whole room painted, and I stop them after 1 hour, what portion of the room will be painted at that point? 1/3, right? Same kind of logic we were doing before. What if it's going to take them 2 hours to, I don't know how long it's taking together. What if it's going to take them 2 hours together, and I stop them after 1 hour? What portion of the room will be painted? A half of the room, right? So you get the idea. So what is it really going to take them?
1 over
X hours together. I don't know what it is. It's X. So what portion of the room will they have painted after 1 hour? 1 over X. Same logic. Got to be. Right? See that? One more time. Let's go over that. If together they can get the whole room done in 3 hours, and I stop them after 1 hour, they'll have 1/3 of the room done together. If together it was going to take them 2, I don't know what's the take them, and I stop them after 1 hour, they'll have half the whole room done after 1 hour. If together it's going to take them X, then stop them after 1 hour, they'll have 1 over X, so they've done it. That's the portion they're going to have done after 1 hour. See how it's the same logic? So what are they going to have done together in 1 hour? 1 over X. If X is the hours it will eventually take them together, then after 1 hour, they'll have 1 over X of it done, won't they? So after 1 hour, Lisa will have 1/4 of it done, Bill will have 1/5 of it done, and together, that'll equal, they add up to equal, what Lisa does in 1 hour plus what Bill does in 1 hour has to add up to equal what they together do in 1 hour, which has to be 1 over X, doesn't it? There's my equation. See how we just logic through that? Solve for X. So you guys are pros at solving fraction equations now. So anyway, you're not going to have to do this every time. Having done this once, let's never do it again. So in other words, from now on, all you have to do on working together problems is just go 1 over a, whatever the first time is, plus 1 over b, 1 over x. That'll always be the formula we use when they have two pipes or two people or two computers working together. It's just 1 over a plus 1 over b equals 1 over together, or 1 over x. That's always the formula we use. Does that make sense? On that, that's the working together for you. Put that in your 3x5 card for every working together. Well, really, I should be a little more careful. It's not always x on the right side. It's together, which is usually x. Sometimes they'll be more tricky. You'll see. So there's the general formula you want to put in your 3x5 card for the exam in 2 weeks. 1 over a plus 1 over b is 1 over together for all working together problems. All right, let's get to it then. 1/4 plus 1/5 is 1 over x. Let's find out how long it does take them. 1/4 plus 1/5 is 1 over x. So that's an equal sign fraction problem. That's why we just spent that whole section solving equal sign fraction problems, so that we can do it now. So how do we solve when you have an equal sign in fractions? Common denominator. You shop the common denominator. You're going to multiply all those denominators together, right? 4 times 5 times x. 20x. Don't forget the x, right? He's under a bar also. So 20x. What do you do with the common denominator? Top, right? 20x, 20x, 20x. That's what we've been doing last hour and a half, right? Common denominator, top. Here's, oops, my thing flipped out on me. There we go. Here's the equal sign. Right, and then we cross cancel. So 4 goes into 20. How many times? So bring down 5x. 5 goes into 20. How many times? 4x. And over here, x cancels x. You just have 1 times 20, 20. Huh? Got rid of the fractions, like we always do. Does that make sense so far? Let's keep going. 5x and 4x. 9x is 20. Last step to get x alone. Divide by 9. Now, do they want, what kind of answer do they want? I don't want a mixed number. So 20 over 9. Remember how to change that? Some of your calculators will do it automatically. Be glad to show you after class when hang out. But remember what you do to change to mixed. You divide bottom into the top. So 9 into 20. Long divide, bottom into the top. Remember that? 9 goes into 20 how many times? 2 times. Be 18, remainder 2. So the answer is 2. And then the bottom goes over the left. So that's 2 and 2 nines. Hours. And that makes sense. That answer is reasonable, isn't it? Remember we said it had to be under 3? Had to be under 4. Had to be an answer under 4. Because Lisa could do it alone in 4. So it makes sense. 2 and 2 nines. Reasonable answer. So we did end up adding, by the way, notice. But we added the portions of the rooms they got done rather than the hours themselves. So adding is the right feeling there. Dina, right? I want to encourage your feelings are right. We do add. We good there? Questions on that one? All right, so the hose alone, that's the pipe alone. That's the hose alone. If you just did the hose alone, it would take 28 hours. So how about if you have both the pipe and the hose flowing the water into your pool? How long will it take for both? So this is a working together problem. I think you definitely recognize it on the test. Very unique. 2 things work together. What formula? It's always 1 over A plus 1 over B equals 1 over together. That makes sense. 1 over A plus 1 over B is 1 over together. So pop them in there. So 1 over 19 plus 1 over 28 is 1 over x. We good there? So just multiply those together. And you know what? Let me give you a hint, guys and gals, to help out. You don't need to even find out what that number is. I mean, who cares? Just go 19 times 28 times x. I don't even care what the number is. 19 times 28 times x. 19 times 28 times x, whatever. You know, you just take one of each, right? That's the common denominator. Just multiply them all together, ta. Just like that. And then cancel what you can. Bring down what's left over. So 19 cancels 19, and we have 28x. 28 cancels 28, we have 19x. X cancels x, we have 19 times 28. So let me get that. Now I guess I do need that number. 532. I thought so. 532. All right, and then we good. We got rid of the fractions, right? No more fractions. So now just add those up. 47x is 532. Last step to get x alone. Divide by 47. We got a number there? Is it ugly? So we got to do mixed number thing. Okay. Yeah, let's do mixed number. So bring it up here. So 532 over 47. So you got a long divide. 40 bottom into the top. Just use your calculator, divide, and it'll tell you what, 10 times, 11 times? 11 point something, right? So then you know it's 11. So just divide in your calculator, you get 11 point whatever, but we can't do the decimal. We got to give a mixed number, you know. So just go, that means 11, then take your calculator. 11 times 47, what's that, 475, 518, I don't know, I can't do it. 517, is that what it is? 5, so I just take 11 times 47, subtract that, 3, put a 2, put a 1, 5, 15. So the answer is 11, and then bottom over left. 11 and 15/47 hours to fill that swimming pool with both the hose and the pipe going. So it makes sense the answer is under 19, huh? Which the pipe could do that alone, so it's a little quicker. It's a reasonable answer, isn't it? Everybody okay with that long division last step there? Just use some of your calculators automatically do it. They're super nice. Just changing the mixed numbers for you. I'm glad to help you show you how to do it in your calculator after class. They're all a little different, so I can't just say one thing for everybody. But I'd be glad to help with that. We good there? Questions on that? 1 over A plus 1 over B is 1 over together for all working together problems. So these kind of word problems won't be too bad, right? This is just that simple little formula. Okay, a little more tricky question here. So person A can do it 4 times as fast as B. Together it takes them 10 days. How long for each one alone? So A is 4 times as fast as B. So, you know the game plan, right? 1 over A plus 1 over B, 1 over together. Good so far? So that's the formula we use for every working together problem. 1 over A plus 1 over B is 1 over together. So now, what are we going to do with the 4 times? Couldn't we let one of these be x and the other be 4x? I don't know, whichever one, you can make that one 4x. It doesn't matter which one's which. And the together, they tell us, is 10. So the together's not the x this time, notice. They're telling me the together. There's no mystery on the together. The together, it takes them 10 days. Mystery is how long for each one alone. See how they're coming at it backwards?
So, just in case, like in the future, they ask, they put A as P and Susie, and then they'll ask who P and Susie. So the 4x will be actually the A on this one?
We'll straighten that out at the end.
Okay.
It's actually more tricky. It's actually reverse.
Okay, that's right.
Because remember, what does 4 times as long mean?
No, it takes longer. So that's slower?
No, I'm sorry, 4 times as fast.
Oh, okay.
4 times as fast. What does that mean about their time?
It's gonna be less.
Yeah. So we'll get there. Let's wrap it up. We'll get there. We'll see that bit. All right. So everybody good to hear. Everybody get the general plan. Whenever they say in a word problem, blah, 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 4 times, you know that means 4x. That could be any word problem. Travel, cars, mixture, money, whatever, right? See, I'm just doing what we always do. When they say in a word problem, blah, 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 4 times. We use 4x. One of them is a plain x, the other is a 4x, huh? Is that good? Nothing really new there? Okay. So now, let's solve this thing. So, how do we solve that thing? What's the common denominator? Just multiply those guys together. Don't use the x twice, though, right? So, 4 times 10, 40, and x. Now, really, 20x is the lowest thing, but whatever. 40x will work fine. We'll just do 40x. That's probably what most people would notice, so that'll be fine. So, 40x, 40x, 40x. Everybody good there? That'll be the common. Do you see why I do not use x squared? Remember, we always use one of each item. Right? So 40x, 40x, 40x. Cancel, cancel, cancel. Multiply what's left over. How we do? We running out of gas? I always feel like after these 2 hours, these last 10 minutes we're going on fumes. I've been talking math at you for 2 hours. My daughters swear that any lecture over an hour is unreasonably long. So x cancels x, right? And x cancels x here. And 4 goes into 40 10 times. Am I going too quick? It's making sense? X canceled x, 40. X canceled x, and 4 went into 40 10 times. And out here, what's going to cancel? 10 into 40, 4 times 4x. Right? We good? And that'll be 50 is 4x. Last step to solve, get x alone. Divided by 4. So x will be, what is that, 12.5? So x is, now, they're going to ask me how long for person A and for person B. Okay, so the 12.5 is what? Is that person A or person B or what? Well, here's the, don't look up to the way I said it, because I just put the x and the 4x down at random. I don't know that this is A and that's B. Don't rely on that. That was just random. I said, who cares about the order? Go back to the words. The words are the key. Person A, I want to know person A. It's going to tell me. Here it comes. They're speaking English. We all speak English. Here it comes. Sorry, I was kidding you, but I know it's hard to read word problems. I kid students sometimes say, it's English. It is English. I know, but it's very confusing English, isn't it? Person A can paint 4 times as fast as B. Ah. A is 4 times as fast as B. A is 4 times as fast as B. So one of them is x, and one of them is 4x. That much is clear. Here, maybe I better just figure out what 4x is. What's 4 times that? So if x is 12.5, what's 4 times that? Isn't it, what's 50? Right? Isn't it 50? So basically, those are our 2 answers. See, I'm getting, now we don't know which is A or B yet. I'll get that for you in just a second. But you see where one of them is, one of the times, A and B are x and 4x. We agree there? X and 4x. So 50 hours and 12.5 hours. Those are the A and the B, because one of them is x and the other is 4x, 4 times x. Now, which is which? Well, it says A is 4 times as fast. So if you're faster, what does that mean about your time? It's the lower. A is the 12.5. That's easy to get turned around, huh? And B is the 50. You might just think, well, 4 times, A is the bigger, but no, 4, they're being tricky. 4 times as fast. If they said 4 times as slow, then A would have been the bigger, huh? We good there? A is 4 times as fast. A is the faster. A could do that job in 12.5 hours. How are we doing? Does that make sense? We good there? So how did I do that at the end? When I got X, I went back and said, okay, X and 4X are my A and my B. So I just took it times 4 and got 50. Those are the two answers. Then I just read the words to figure out which one was the lower, which one was the higher. A was faster, lower time. All right, so here we go. So here's what the word problem basically says. So now we're shifting into another kind. And I'm actually doing this to give you a break from, because that other one, that Jake problem is hard. We'll do that next time. So let's just do this is the easiest of the 3 kinds of word problems. These are ratios. These will be nice and easy for you. So it's saying L to W ratio. Now what's a ratio? It's a fraction, huh? It means one thing over the other, doesn't it? Does that make sense? L to W ratio, that's like saying L over W fraction. Is, what is? Equals 1.5. See what that first sentence is saying? They're saying L divided by W fraction equals 1.5. L to W ratio, fraction, equals 1.5. And then what are they saying in the second sentence?
W is 40.
W is 40. Boom. So that means L over 40 is 1.5, huh? So they're telling me W, and they want me to find L. This is the easiest one. So how do we solve that little equation now for L? Common denominator is the 40. Yeah, just multiply, right? Like we always do, whatever the common denominator is, you multiply both sides by whatever's under the bar, huh? Because that'll take out the denominator. So L is 60. Because that's 1.5. That's all of 40 and half of 40. 20 more. Right? 1.5. So we good there on that? We'll try one more of those little ratio ones. Those are pretty quick and easy, I think. Questions on that one? So what else? Number 7. Cambridge Slim ate 59 sausages in 20 minutes of a high-stakes eating contest. Ugh. Assuming that he continued at the same pace, how many sausages would he have eaten by the end of the 30-minute contest? All right, so number 7. How many? He ate 59 in 20 minutes. 59 sausages. That can't be good. In 20 minutes in that poor stomach. 59 sausages in 20 minutes. How long in 30 minutes? Or how many? So if Cambridge Slim ate 59 sausages in 20 minutes, how many would he eat in 30 minutes? So that's a ratio. This is the second. Okay, we're going to have 3 kinds of word problems. We had the working together. Now we're doing ratio. And then Wednesday we'll do travel, cars and trains and things. Anyway, so this is ratio. So in the ratio ones, what you basically do is have I'll just write it over here. A over B equals C over D. You have 2 equal fractions. 2 equal fractions. That makes sense, what we're doing? 2 equal fractions. So here we go. 59 sausages in 20 minutes. 59 sausages in 20 minutes. I think it helps, you don't have to put the words in there, just so you know what on the top and bottom. You could flip it. You can put the 20 on the top, 59 on the bottom. Doesn't matter. The words might help you. 59 sausages in 20 minutes equals. Now on the other side, the other fraction, I've got the number 30. Where's the 30 going to go, top or bottom? Because I happen to put minutes on the bottom. It'll go on the bottom. What do you think goes in the top blank? That's my X. That's how many sausages he's going to eat in 30 minutes, right? 59 sausages in 20 minutes is how many sausages in 30 minutes, if he continues at the same rate. Just piling them in. I like sausage, but, 59. It can't be good. So, how do you solve two equal fractions? Cross multiply. Diagonal, diagonal. 59 times 30 is 20 times x. I need a number one. 1770. Thank you. 20x. Last step to get x alone.
88.5.
Divide by that 20. Yeah, what does it come out to be?
88.5.
88.5 or half. I don't know if they want decimal fraction, what they want. Yeah, you can either go 0.5 or make it 88.5 if they want a mixed number. They'll tell you what they want. I guess I could go round, so they want me to say 89. Because 88.5 rounds to 89. So 89 sausages in half an hour. There we go. Is that making sense? So this middle kind will be the easiest kind for you. These are just ratios. These are nice. These aren't bad. All right. What did we...